Design inputs. Inputs are mandatory in any design, irrespective of the type of project that you are working in order to finalize your design. Especially when it comes to process piping design, you need to have certain level of input in order to start your activity, and those inputs are considered to be a very critical inputs. So in this video, I am going to explain you those critical inputs so that you will be able to understand how the real-time project works. Without wasting your time, let's get started. So in any project, irrespective of the size of the project, irrespective of the type of a project, whether it is greenfield or brownfield, you should know as a piping design engineer what are the necessary inputs that you need to have in your hand in order to start your activity. So if you conveniently understand these inputs, actually, you will be able to work in any project. So you don't have to bother about the type of project. So basically, these inputs are almost similar to greenfield and as well as brownfield, but there are some dynamics varies between these inputs. So let me explain those critical 15 inputs in this video. Let's start with the first one. The first one is, when you start any project, you should understand the intent of the project. So to understand the intent of the project, you will be having something known as scope of work. So scope of work, to put you in a very layman's language, it defines the necessity and the purpose of a particular scope that you are going to design. For example, a client comes out with some requirement. It could be an installation of the pump, or installation of pressure vessel, or a replacement of existing piping, or replacement of support. So the basis and the purpose and the necessity of these requirements will be defined in a document which is known as scope of work. Remember, the scope of work is not a document only for a piping. This is a scope of work which is for the entire project. So this will have the theoretical explanations, it will have substantial facts and the productivity improvements, and what are the benefits that the clients are going to get by implementing these solutions, and what are the different options available, and why did they choose a particular option. So every details will be available. So basically, this document is to understand the intent of the project in a very schematical way, I would say. So if you are starting any project, you should know the scope of work of that particular project. So this is the first document. Second document is PFD. PFD, I think you are all aware about it. It's process flow diagram. Process flow diagram shows you a schematic, overall schematic. It doesn't show you the small bore lines or all isolation valves. It will only show you the critical isolation valves and the major equipments. Even it doesn't show the number of exchangers. It will only show a type of an exchanger where the heat exchange happens actually. So through PFD, you will be able to understand the scheme of the project. But in order to understand the details of the process, then you will have to refer the P&ID. So the third category is P&ID. In P&ID, you will be able to find all inputs. All inputs in the sense, you will be able to find the equipment, line size, and whether it is insulated or non-insulated, or traced or non-traced actually. What is the line size, whether it is sloped or not, where it is connecting, do you have the drain, vent, and you have the isolation valve, control valves, and every details will be available with respect to a particular line. So P&ID will be able to help you with the exact detail of the scope. It will show you the tie-in points, it will show you the cut points from where to where exactly the line has been replaced, and what are the new lines and which equipment is installed. Those details are shown in the clouds. So P&ID is one of the very critical documents that you need to have in order to start your activity. So once P&ID is done, actually, the very next thing you need to have is then MOC. What is MOC? MOC is nothing but material of construction. So there is a team known as an MNC team. They works with respect to the materials based on various parameters, especially the compatibility of the fluid or the services that passes through the piping. So you will receive an inputs about the MOC from the MNC team. So once you know the material of construction, it could be a carbon steel, it could be a stainless steel or alloy steel or whatever actually. So based on the design conditions and based on the MOCs, you will be able to finalize the piping class. The next one is a line list. So what does line list shows? Line list shows the details of the lines that are being modified. For example, what is the line number, what is the design temperature, what is the operating temperature, what is the insulation thickness, whether it is toxic or not, and what is the in case of any upset condition, whether upset conditions are defined, the temperature of the upset conditions are defined, whether it is tying with the header. If it is tying with the header, what is the line number of the header, size of the line, whether it is a hydrocarbon or utility, all details you will get from the line list. Okay. Why line list is required? Because you will know the number of lines that you are working. So from this you will take out the critical parameters such as design temperature, design pressure, operating temperature, operating pressure, which are required in order to finalize your piping class as well. So line list is one of the critical document that you need to have in order to start your activity. All the document that we are going to discuss over here is necessarily required in order to start your activity, because your design is a combination of inputs that you are going to collect from these documents. Let's go to the next one. Piping class is the next document that you need to have. Piping class is nothing but segregation or standardized piping components, where you will find the pipes, fittings, valves, bolts and gaskets for a particular temperature and pressure range. So this document has standardized in such a way that you will be able to use this particular component in any lines which applies within this particular temperature and pressure range. So you must be well conversant in reading this piping class, so that you will be able to choose the right fittings and right valves and the combination of the gaskets, bolts and valves and all actually. So this is a vital document. The next one is see, when you have a necessary input such as a PNID, PFD and piping class and MOCs, but still you need to have some requirements from the clients, because you are working for a client actually. So you need to understand the basic requirements of the clients. What is the design requirements of the clients? What is the quality requirement of the clients? What is the document requirement of the clients? All these things you should know. For that, you need to have the client specification. So what does client specification includes? Client specification includes a set of standards which is exclusively to be followed for that particular client. So the client will share these documents to you, so that you will have to go through these documents in order to understand the client requirements right from documentation. Let me just read out one by one. So these are very interesting documents. If you have these documents, it will really help you to in order to meet the client expectation in your design. Let me start with actually the first one is you need to have is the documentation requirements of the client, how the document number needs to be mentioned, and what is the document type and what is the unit code, area code. All these details will be available. Especially in documentation requirements, you will understand what are the approvals required for different drawings, such as a piping layout, plot plan and isometrics and MTO, whether it requires a client approval or not actually, and what is the documentation requirements that you have to follow for the vendor, what are the minimum documents that you need to submit for the vendor scopes. Basically all these details will be clearly given. So this is known as a documentation requirement. The next is that you need to have a piping layout specification, you should have a piping stress specification, pipe support specification, insulation specification, painting specification and equipment layout specification and human factor engineering specification. Let me see whether anything has been missed or not. Yes, so these are the very important specifications you need to have from client. So these specifications will help you in order to understand the client requirement. Also, there are some vital conditions are given in this document, so that it will help you in order to finalize your design very easily. The next is design procedure. Generally, design procedure varies from client to client, but however, being a piping design engineer, when you're working with a certain client, you should know about the design procedure of that particular client, because they will have some expectations to conduct a design review, hazard review or 3D model review, like a 30% when, 60% when, 90% when to release the MTO. All these procedures are defined in the design procedures. So it's necessarily important to understand the design procedure, accordingly plan your project. Otherwise, you will not be able to plan the documents according to the client expectation, because there are necessity where you need to deliver certain documents in the early stage based on the design procedure, and there are documents you can deliver during the later stage also. So based on the client, based on this procedure only, you are going to execute your entire project. So that is why this document is critically important. The next detail you should have is the dimensional details of pipes, fittings, valves or any standard piping components. You should have this dimension in hand, only then you will be able to start your designing activity. In case of 2D, you should have this dimension details, but where in case of a 3D, you should ensure that these components are listed in the 3D database. So that is your critical part. So when you verify the database, if you find that there are components which are listed in the piping class are missed, actually you should call the database administrator and ask him to include the particular details which are missed basically. So basically you should have the dimensional details. In 3D, when you develop a database, automatically the database administrator will be able to include all the dimensions of a particular component, so that once you select a component, automatically the component will be placed in the platform with the respective dimensions, so you don't have to worry about it. So in 2D also you can create a database for piping components and valves actually with respect to the given dimensions. So basically you need to have this dimension details in your hand. The next document you should have is that existing drawings. Existing drawings such as plot plan, key plan, piping GAs, piping key plans or unit plot plan, all the existing drawings you should have. Where in case of greenfield projects, you will be developing the plot plan as well as the piping GAs and unit plot plan. However, you should know the approved layout. You should have the approved grade plan so that you will be able to design your plot plan accordingly. So without existing drawings, and you will not be able to start your activity because you do not know the size of the plot, you do not know the elevation of the plot. All these things needs to be received from the client actually. So especially if you're working in a brownfield project, with reference to the existing drawings only, you will be able to initiate your project activity. In case if the project is 100% 3D projects, you need to have the 100% archives, database and structure of the 3D model which are being used by the client, so that when you have the same system over here and once you update the 3D model, you can send the archives to the client so that your model will be reflected in the client server also, and whatever the client server's data also will get transferred to you. So you will have the transparency between both the parties actually. So where in case of a 2D, you need to have the existing drawings, where in case of a 3D, you need to have a similar setup of whatever the clients are having with your company as well, so that you will be able to update the 3D model with the client side also. The next important thing is that individual equipment details or drawings. Especially when you're starting a project, you may not have the individual equipment drawings. For that, you will have to go with the reference. For that also, you need to get the process details. You will be able to find the reference equipment drawings with respect to any previous projects or drawings that are generally being shared by the static engineers. So from that details you can go with, or they will provide you a schematic equipment pressure vessel drawings that will show you the elevation, nozzle size and overall dia of the vessel. So you should have these details in order to start the piping, because you do not know the rating of the equipment flanges, what is the size of the nozzle, you do not know the height of the particular nozzle elevation. So all these things are required actually. So where in case of during the detail engineering, you need to have the final drawings from the vendor. So for that, there are a lot of procedures are available. For example, that you need to float an inquiry, you need to get the vendor code, you need to approve the vendor, you need to get the final drawings, only then you can implement it. However, in order to start your activity, you can start with the reference drawings from the previous project, or the reference drawing shared by the static engineer, or you can wait, you can keep that particular informations in hold, and when you get into a detail engineering, you can finalize with the final vendor drawings. The next detail you should have is instrument details. What are instrument details? What is the type of an instrument? Whether it is the pressure gauge or temperature transmitter or level indicator, what is the end connection, what is the overall dimension of this instrument, whether it can be suited in your existing layout or not. All these things you need to verify. For that, you need to have the dimensional requirements and the end connections. You need to have the end connections, only then you can arrange the similar end connections to mate with your existing piping. For example, for a screwed connection, you will provide a screwed connection. For a flanged connection, you will provide a flanged connection. Similarly, for a welded connection, you will be providing the welded connection also. The next input you should have is that piping specialty items details. So what are piping specialty items? There are many piping specialty items are there. For example, filters, strainers, rupture disc, and orifice, flanged spools actually. All these things are considered to be a piping specialty items. You need to have the rating, you need to have the size, you need to have the dimensions of this so that you can include in your piping design. Unless until you receive this information, you cannot finalize it. But in order to start your project actually, you can keep this information in hold by considering some assumed value. But however, during the detail engineering, you have to finalize all these dimensions. If you don't finalize it, you may not be able to produce the right isometrics or finalize the piping GS also. So that's one of the reasons why these inputs are required. The next is valve details. You should have valve dimensions, rating and size in place with an approved drawing in order to start your activity. For example, if you don't have this information, actually you can keep it on hold, but you cannot finalize your design. So you need to have the exact size. Most of the valve dimensions are taken from the standards, so you will not face any issue for the face-to-face dimension. But however, the handle length, what is the handle wheel size actually, in case of the body, what is the actual size of the body, whether you have enough access for the bolting removal or not, what is the flange thickness, all these things you should have. What is the rating, final rating which is given in the valve drawings actually. You should have these details in place. Only then you will understand whether the valve occupies a sufficient space or not, and in case if it occupies a sufficient space, whether it is clashing with any other particular line which is running near to this particular valve or not, whether you have an accessibility for the nearby valve or not. All these requirements you have to finalize. So in order to finalize it, you should have the approved valve drawings so that you can clearly verify those drawings and finalize your design. The last but not least is, the next is control valve and actuator detail. See, control valve is considered to be a critical component in process piping, because control valve, it controls the critical parameters such as pressure, temperature and flow. So generally CNA or the instrumentation team are the one who procures this. So mechanical team do not have the dimension details of this control valve. So unless until you do not know the dimension of this control valve, you will not be able to finalize the control station design. Basically, you need to have the actuator size, actuator length, and how much projection is required, how much width is required, whether the actuator is a horizontal or not, whether it is a vertical, and whether you need to have any additional space to be provided in the control station. So all these things needs to be assessed only after getting the final control valve and actuator details. So that is why this is very critical item. Hope this video has given you an idea about the design inputs that are required for a piping design engineering. I will meet you in another fantastic video. Until then, bye from Subhash Chandran.